Okay, so far, the only way we've had to find zeros of a parabola is what? We could use the big F word.
Factoring.
Factoring, great. So we have different kinds of factoring. The problem is, I think you've run into a couple parabolas. I see some grins out there, I see it. We've run into a couple parabolas that didn't factor. Well, the question is, do all parabolas factor? The answer is no. Some parabolas don't factor, and you still need to be able to figure out their zeros. Some parabolas actually have things called imaginary zeros. So there's other ways to solve parabolic equations, and we go through them all really exhaustively in Algebra 2, pretty quickly still. But we will come back and review some of these things. The one that's probably the biggest, the one that always works, is the quadratic formula. So I'm not going to derive the quadratic formula, show you where it comes from today. There's several ways to show that. None of them are accessible to us yet. We need to know more math. So we'll see where that comes from in Algebra 2. But I'm just going to hand it to you and we're going to use it. Okay? So that's the point of today, is solving parabolic equations using the formula and not factoring. But you want to be efficient because using the formula takes a while. So if you can factor something, you probably want to factor it over using the formula. But it's up to you somewhat. So like on the test, if you run into one of these and you use one or the other, I don't care. I'm not going to say you have to do one this way or that way. So what is the quadratic formula? This is something you need to memorize. I'm not going to give it to you on the exam. So you're going to see it today, you're going to see it Thursday again. You know? Yeah, what is it? So you've already seen that part of the quadratic formula. That comes from the vertex. That's the vertex formula. So it's actually very related to the vertex formula. They are one and the same concept if you look at them the right way. I don't know if we'll talk about that today, maybe on Thursday. But quadratic formula says take the b and go plus or minus, because most parabolas cross how many times? Twice. That's why you go plus for one way, minus for the other way. And then you go the square root. And inside you have b squared. Minus 4, there's always a 4, just like there's always a 2. And the 4 gets multiplied by a and c. Okay, so that is the quadratic formula. Now if you're looking at it and going, man, that's beastly, I'm sure you can memorize it. If you start doing in your assignment and you do all the problems, you're going to have it happen automatically. So write it down every time. Don't keep looking in your notes and just relying on your notes every time. Write it down every time, and by the 8th time you do it, you'll have it memorized. Okay? So let's use the quadratic formula on both of these problems. Now they might factor, they might not. I'm just going to pretend that I was too asleep to try to factor them first. Okay? So this guy is set to 0, he's ready to go. Can you guys tell me what are A, B, and C?
A would be 6.
Let's write it down. 6. And I'd write this down for yourself. Make it easy so you don't make a mistake. B is
Negative 5.
5, C is, yeah, there you go. Okay, so now, just like I'm going to do in the homework, first I'm just going to write the formula down. So, trying to remember it, I think it's negative b plus or minus square root thing over 2a, and inside goes b squared minus 4ac. Alright, so now I'm going to plug in my numbers. Notice, it pops out the answer right away, you just have to simplify. That's the answer, x equals whatever. So I'm going to say, well, negative 5 plus or minus, what's 5 squared? You can write 5 squared in there if you want. I recommend just saying, what's 5 squared? 25. It's 25. By the way, this part should never be negative, because if you square any number, squaring makes all numbers positive, yeah. Positive, yeah. Minus 4 times what's A? 6. C? Negative 4. And then it's all over 2 times 6. You know, I'm not going to write 2 times 6. I'm just going to put 12. How much work shows up to you? So now, there's the answers right there. They're right there. The only thing is they're not simplified yet, so I need to work on them. So order of operations says, where should you go to simplify stuff first? Parentheses. There's parentheses here. That's the inside. Exactly. So we're going to go negative 5 plus or minus. We're going to work on the inside. I always like to count my negatives here. How many are there? 2. Negative times negative is Positive. And then I'm going to use, you can use your calculator on this. I'm going to say positive, because this one I do need my calculator on, because it's really what? 4 times 6 is 24 times 4. Can we do that in our heads? Some of us might be able to. What's 24 times 4? 25 times 4 is 100. So it's 96. So by all means, right there, if you need to, use your calculator, okay? So then we've got negative 5 plus or minus. Still on the inside, what's 25 and 96? We might need our calculator, that's cool. I think that's going to be 121. Now, at this point, sometimes your quadratic formula is not going to work out as nice answers. This time it worked out as a nice answer. What is the square root of 121? That's a nice answer. That's 11. Sometimes it's not going to. If it works out as a nice answer, that means your problem could have been factored. If it doesn't work out as a nice answer, that means your problem could not have been factored. Does that make sense? So that's kind of what it means if the square root comes out nice or not. So I'll do at least one today where it doesn't come out nice, just to show you one of those, okay? So let's see. So we got 2 different answers here. So you want to write them in 2 different spots. So I'm going to say answer 1. Use a bullet point. It's negative 5 plus 11 over 12. That says 11 minus 5. Is that 6? So one answer here is a half. So there must have been a factor with some kind of half thing in it. And then I'm going to write my other answer separately, negative 5 minus 11 over 12. So that's going to be negative 16 over 12, which you could leave. I mean, if you left it as that, I'd be all right, but 4 goes into both. 4 times on top, 3 times on the bottom. There's the 2 answers to this guy. So if we were going to graph this parabola, your problems this time don't say graph, but if we were, we'd know there's an x-intercept right by 0 on that side, and right by negative 1 on the other side. We could graph our parabola. This would be going up, do our vertex thing, you know, all that stuff. But your problems are mainly going to just ask you to factor on this first little assignment, okay? I mean, excuse me, to find the zeros by using the formula. So, let's look at the second one. So let's try to be efficient this time. So we could use the formula or factoring maybe. Before we decide, what should we do first, guys?
Get 0.
Get 0. Very nice. So you can get 0 by moving stuff either way. I'd always try to keep your x squared positive. So that's my advice, is to move stuff this way. So I'm putting 0 on this side, if you will. So I've got x squared, I've got minus x, and I have 20. So now you guys tell me, given the choice, should you use the formula or should you factor that? Does it factor? And that'd be a lot less work, so on this one I'd totally factor it. Five and 4, Richard? 5 and 4 work on this one. So much less work. To go x, 4, x, 5. Richard said negative 5 is the one. So then the answers are going to be what? Exactly. That is a lot less work than using the quadratic formula. So I would totally do that. And on your assignment, even if it says use the quadratic formula on all of them, I don't care. If you see something that can be factored, do it the easy way, okay? Like, that's totally the way anyone that's alive would do things, is they do it the easier way. So that's a lot easier. If we'd used the formula and gone through the process, those are the answers that would have popped out. Okay, let's do one more as an example. Okay, so one more problem, guys. So I'm going to give you a problem. You guys can decide whether you want to try to factor it or use the quadratic formula. So let's look at this guy. So there we go. That's the problem we're asked. What do you guys think? Can we factor it? What do you think about it? You sure?
Yes, we can. Isn't it already in there?
What are the only factors that could be? Combinations of 1 and 7? 1 and 7 going to give you -3 somehow? Totally not. So this guy won't factor. This is one where you have no choice. So we've got to use the quadratic formula. So let's see. So I totally wrote this one down randomly. So x equals, I'm going to write down the formula. That's what you guys should do, and try to do it without looking. That's how you'll memorize it. So there we go. It might take you a little bit more thinking. Bless you. So, how are we going to do this? Oh, and what else did I forget to do? I forgot to write down to set it up. A was what?
A was
1. -3. Okay. So now I can plug them into the formula. That's how a formula works. You should be plugging stuff into it if it's truly a formula. So we've got negative from the formula, and then negative from the b. Guess we're talking, better watch. And I've got plus or minus b squared. So you can write b squared, but see, some people will do that. That's not correct. Somebody tell me why that's not correct. Why? Some of you are going to write this down on your paper if you're not paying attention. And then you're going to write on the next step, well, that's +3. And then you're going to tell me -9 here. And I'm going to go like, what? +9. Exactly. Because it's +9. Why?
squared.
I'm not squaring the 3 and then attaching a negative. See, that's what this says. You put this in your calculator, it's going to tell you -9. What do you really want to square? The quantity, all of it. So that's what you've got to do. So that's why I wouldn't even write this down. I'd just say to myself, what's -3 squared? Negative squared is +9. Okay, so that's up to you, but lots of people make mistakes right there if you're not careful. Anyway, so then we have to finish -4 times 1 times 7. And we're going to go over 2 times 1. All right, so we've got 9. Just 1 minus is minus. 4 times 7 is 28. I don't think I need my calculator for any of that. See, and here's an issue, which isn't going to happen on any of your problems this year. I just made this up randomly, right? So because I made this up randomly, what's 9 minus 28? Negative, I like that, negative 19. Do you know the square roots of negative things? You can try all day to try to figure out what the square root of something negative is. You're not going to be successful unless you're like a super genius. So that's an imaginary number, which we're not going to cover this year. So I'm going to change this problem to give it real answers. Because this parabola doesn't have any intercepts. Since this is going to come out to an imaginary number, that means this parabola is totally above the axis. There's no answers, no real answers. There are answers, but they're not real. Crazy stuff, right? Yeah, this is crazy stuff. So that's the danger of just writing down any parabola. So how can I fix this parabola to make that not happen? I think I could have said instead of +7, -7. You guys won't have to worry about this, but it's a good issue to talk about. So that makes C -7, which makes, just C is only in here one spot, right? Right there. So that's -7. What's negative and negative? Positive. Okay, so now we'll get a positive square root, which will be doable. So let's see, we'll get 3 plus or minus square root of 37. You guys know the square root of 37?
Yes.
Guess.
Square root of 36 is 6, so
Square root of 36 is 6, so 6.1, 6.2, something like that. Let's use our calculator to finish this now. So go grab your calculator. Okay, so here's how you enter that in your calculator. We wanted to do 2 separate problems, right? One for plus and one for minus. So on your calculator, do it separately. So let's go and use, you guys remember how to get a fraction in your calculator? Because isn't that a big fraction? Somebody tell me how to do it.
You go second.
Close. You go alpha
Oh.
y equals. That's the easiest way to get a fraction. So it'll serve you well.
I was going to.
So if you have an 83, that's not going to work, Richard. So I'll do it two different ways here, okay? So one way to do it is to get a nice fraction. So I'm going to say 3 plus the square root. Square root's over on the left-hand side of your calculator. It's in blue. So 3 plus the square root of 37 over 2. There's one of our answers for this parabola. One of its zeros is at 4.5413, etc. And then, so anybody need some help on that? So you can't do this way, Joe. You're going to have to wait.
I got it.
So that's one of our answers. Write it like this. You said -1's the other answer, Colton?
-1.54.
Okay, so you could of course type that all in again, but I'm lazy and efficient. So I hit second entry. I hit second enter. It pops the same thing up where you could scroll up and grab it. And then I'm going to go over and put a minus there instead. And you guys are right, -1.541 is the other answer. Now, if you have an older calculator like a TI-83 or something like that, here's how you do it. Joe, Richard. Fractions need parentheses, so you got to go parenthesis, 3 plus square root of 27, end parenthesis, 37, thanks guys, and divide by 2. I don't need to put parentheses on the bottom because 2 is the only thing down there. If there was anything other than 2 down there and I wanted the calculator to read that as the bottom, I'd have to put parentheses around it too. Okay? And there you go, same answer. And if you have an old calculator, it'll still work. You can still hit second entry, pop that up, and change it, or you can type it in all over again. So there's your 2 zeros for this parabola. Notice, not so nice answers. This could not have been factored. There's no way to do this without the quadratic formula or fancier math. Okay? Okay, so in this section, there's one other thing you guys should be aware of, and this thing is pretty brief. So we've got the quadratic formula there, right? There's a certain part of the quadratic formula that makes things easier for you if you care to be aware, alive, a thinking human being, in other words. So, for instance, if it asks you, find the number of solutions for a parabola, a quadratic equation. How can you do that without actually finding them? Is there a shortcut? Yes, I can look at these and immediately tell you how many answers they're going to have. Are they going to have no answers, imaginary? Are they going to have one answer, the parabola just touching the axis? Or is it going to be like most of the time where the parabola goes through twice? Something in that formula tells you that, and you don't have to do the whole thing. So let's talk about that part of this formula which tells you how many answers you're going to get. The part that tells you how many answers you're going to get has a name. Doesn't really matter if you remember the name. Not really an important name unless you like trivia like me. But it's called the discriminant. So this is the part of the formula that tells you how many answers you'll get. It's really fast to use the discriminant. The discriminant is this part. The inside part. Let's think about why. So I'm going to use it. Using it's very easy. Why does it tell you how many answers you'll get? Well, think about the formula. If the discriminant is equal to 0, then you're going to have plus or minus the square root of 0, right? What's the square root of 0? 0. So in other words, you're going to have stuff, negative b stuff, plus or minus nothing. So the plus or minus doesn't even matter anymore. So how many answers are you going to get? 1. You're going to get negative b over 2a. You're going to get the vertex, because for a parabola that has one solution, the 0 is the vertex. That's if the discriminant is 0. So let's say if the discriminant is 0, we should think about this picture. We're going to get one solution. In other words, one x-intercept for the graph. most of the time that doesn't happen. That's pretty rare. Most of the time you're going to get that the discriminant is something positive or something negative. So if the discriminant is positive, then you're going to have an answer in there, like 37, like we had a second ago, or 25 that comes out as nicely as square root of 25 is 5. It could come out nice or not. But if there's something positive in there, you get how many answers? 2, because outside you've got plus that thing, and then separately minus that thing like we just did. So that's going to be 2 solutions. That's what's probably going to happen most of the time. The thing which I don't think any of your problems will do, but they might. What if it's negative inside, like a second ago where I made that one up and it came out to like negative 19? That's where you're not going to have any solutions because they're imaginary. That's because the parabola in this case looks like this. It's not touching. Or it could be over here, something like that. Looks like that and not touching, right? This parabola looks like this or like this. It's got 2 solutions both times, and that parabola just barely kisses the axis, and its vertex is the same thing as the 0. So that's what the discriminant can tell you. So using it is really quick. So let's see, for this guy, what is the discriminant? It's going to be 11 squared minus 4 times 2 times 12. So that's 121 minus 8 times 12. You can use your calculator at any point in here when you need it. 8 times 12, 8 times 10 is 80.
96.
That's 96. And see, I don't even care what this comes out as, because right here, you guys tell me, is this going to be 0, positive, or negative? 121 minus 96? I don't care what the number is. I care that it's going to be something positive, so I'm going to get plus or minus stuff. So how many answers am I going to have? 2. So notice how quick that can be. So if we've got something like this, the discriminant, let's see what it turns out as. So this time B is 8, A is 1, C is 16, 64 minus 4 times 16, you might need your calculator there. That's 64. See, that one's a rare one. It came out as perfectly 0. So what's that mean this parabola looks like? It's just kissing the axis. It's just got 1, 0. And actually, its 0 is the same thing as its vertex. So it's pretty a nice parabola right there. It's a perfect parabola, actually. That's what they're called. Okay, so that's using the discriminant. That's all that's in this section. Either using the discriminant, but more importantly, using the quadratic formula. So if you use the quadratic formula and you get answers that come out as not nice, make sure you record them to 3 decimal places. Okay, guys? So.